Hello, math fans. This is Dr. Andy Lovelace. I'm going to talk about the basic idea of equations for planes in 3D. I'll show you a few visuals, talk about some facts, and then in future videos we'll talk about how we actually find them. If somebody says find the equation of a plane, and then there's a bunch of information, blah, 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 whatever it is, I tell students the following. At the bottom of the page, you're going to write this. And your job is to figure out 6 numbers. And in my class, we talk about what those numbers represent, but there's these 3 numbers, which represent what are called a normal vector. So what you want is a normal vector and a point. A point on the plane and a normal vector. And here I tell students that they really do want to draw the following picture. So let me have that off the screen for a second there. You say, well, it's still almost off the screen. Okay. So the picture to draw is this. This is something kind of, I don't know if this is an innovation, but I've taught this course for 20 years. The last 2 years, I've told students that every time you see these words, you're going to draw this picture and write this equation. That's just going to help control your thinking. On the picture, I'm going to draw a normal, and I'm going to draw a point and say, those are the things I'm trying to find. And if I can find this normal, A, B, and normal just means perpendicular, we usually call it N, I'm going to put those 3 numbers here. So it's important to understand conceptually what you're after when you do this. Okay, so those are the 2 things we want. That sometimes will involve using some of our vector skills to do this. But let's just talk about this a little bit. So there's a plane. And often what happens is you're given 3 points. So you have 3 points. Let me get rid of some of this other stuff so you can't see it for now. And then I'll show you a few other things. So there's 3 points. Those 3 points form a triangle. If you extend that triangle in all directions, it's a plane. And I think for now, let's get rid of the axes. They're kind of in our way, the grid. Okay, so if you extend that in all directions, you get the plane. And we would like to describe every single point that's on there, not just those 3, and what they all have in common. Now in my class, I'll talk about why it's a little bit longer explanation, but you can't use slope because there's an infinite number of slopes. You can get a couple vectors on there and take their cross product. So the overarching strategy, which I'll talk about in class, is you need this vector and this 2 vectors on the plane. There's an infinite number of slopes on a plane, so to speak, vectors, but there's only one direction that's perpendicular to those. And that's the clever idea. I think of it as the tilt vector, a vector that sticks straight out of it. And the clever observation is that if you draw a vector between any points, whatever they are, so here's a vector, these are 2 vectors that point from the origin to my plane, to 2 points in my plane. If you connect them, that vector that connects them must be perpendicular. So the whole idea of the equation of a plane is that the orange vector and the green vector need to be perpendicular. So just I'll do a very brief. So if you have this point, this is the point you already know. We need that. And then you have some other point you don't know. The entire idea is based off of the fact that if you connect those 2, these 2 vectors, the orange vector and the green vector, will be perpendicular to each other. And that's where the equation comes from. Because the way you get the vector between those 2 points is x minus x0, y minus y0, z minus z0. And in order for them to be perpendicular, the dot product needs to be 0 with this. That is the clever idea for the equation of a plane. Now, once we have that, we don't usually write it as a vector. The vector just explains it. That's beside the point. You need a point and a normal. That's it. That's what you need. And it doesn't matter where that second point is, that orange vector will be perpendicular. So that's the visual idea of what is going on here. Cool? Clever, I feel like. So we're searching for that tilt vector. Now let's say a few things about planes. So you can have two planes that are parallel. A natural question might be, what's the distance between them? And we'll talk about like what the numbers mean and what we can do with that. The way I visualize a plane is I often find those three intersections and draw the corresponding triangle if someone forces me to visualize it. You can have two planes, so they can't be skew. Two planes are either parallel or intersecting. If you look around the room you're in, you're going to see the ceiling and the floor and the walls in front of you. Some of those are parallel, some of them are intersecting. That's only two things that can happen. So here's an example of intersecting planes. They can't be skew. In fact, when they intersect, you should see that they form a line. That's a question we'll talk about how to find it. We'll talk about how to find that line. That purple line there, that's the intersection of both of them. Now, if you go back to the line discussion, you only need 2 points. That bothers students that you only have to find 2 points and you're done. That leads to a certain strategy of how I do these problems, which is somewhat different than how some others do it. But all those methods will work. So there's a little discussion of planes. You want a point and a normal. Two planes can be parallel or intersecting. Now we can have a little discussion about the distance from a point to a plane. Historically, we used to do more of this in the course, and the textbook does quite a bit of this. We don't have, I think there's one homework question, and they give you the formula, so it's actually really short. Because we don't do this as much, I often teach it differently. What I tend to do, and if I'm faced with a problem like this, what I would do is I would find the line that points straight out of it, find the point of intersection, and then use that to find the distance. It turns out all of that stuff we can do fairly quickly. There is a shortcut formula, like I said, I don't emphasize it as much, that computes the distance. And it says take the point, plug it into the formula, do this division. So that's a great formula. It's really popular to be taught. It's something, I'm not into these things I have to memorize if I can solve it by some other means. You can also solve it with projections, which is where the formula comes from. I might make a supplemental video on that. It's just not a major point of emphasis in our course anymore, so I won't say as much about it. So that's more, if you're interested, let me know. Okay, so there's a little intro to planes.